Hi and welcome to another episode on my channel. Today we're going to build your very first AI agent in UiPath. We'll be helped by Autopilot, which will guide us through the process step by step. If building AI agents is something you'd like to learn, I warmly invite you to watch this video. Together we'll build your first agent inside the UiPath Studio Web environment. After watching this video, each of you should be able to build your own agent, understand how Agent Builder works, and know how to modify it according to your needs. So, let's get started! What will our agent be responsible for? Planning a team lunch can be a challenge. You need to pick a restaurant that suits everyone, fits the budget, and can accommodate the entire group. Today, I'll show you how to solve this by creating an intelligent agent in UiPath Studio Web with help from Autopilot. This agent will be able to find a restaurant for the team lunch based on provided criteria using live data from internet. During this episode, we'll go through the entire process, from creating the new agent with Autopilot to defining prompts and arguments, adding tools, testing the agent, and discussing the results. Let's start by creating a new agent in Studio Web. We choose the options Create New Agent. Studio Web offers two approaches. We can either start from scratch or use the Autopilot assistant, which generates an initial agent based on our description. In this episode, we'll go with that option. In the description field, we describe the agent we want to create, its goal and requirements. Let's first enter a prompt describing the task for the agent. A prompt is simple and detailed instruction of what the agent should do and how it should behave. Okay, we've just created our prompt. In our case, it includes, among other things, the agent's scope of action. We inform that we're creating an AI agent to search for suitable restaurants for a team lunch based on given criteria. The agent should accept four parameters: city, cuisine type, number of people, and budget per person in Polish zloty. Once it receives this impulse, the agent should search for restaurants that match the criteria. It must ensure the restaurant is in a specific city, offers the selected type of cuisine, can seat the given number of people, and that the cost per person fits the specified budget. For each found restaurant, the agent should return a text response including the restaurant's name, a short description, rating, and possibly a recommendation. A short note about what makes the place stand out or whether it's recommended. If the agent doesn't find any restaurant matching criteria, it should inform the user and suggest how the criteria could be adjusted. For example, choose another cuisine, increase the budget, or broaden the search area. A well-written prompt clearly defines the agent's role, its goal, and how it should behave. It tells the agent what it is, what it should do, what impulse it will receive, and what should be included in its response. The structure of the prompt resembles step-by-step instruction or requirements. that helps the AI model understand the task and plan its response. Alright, let's click Generate Agent. Autopilot will now analyze our prompt and suggest how to build the agent. Okay, we've received suggestions from Autopilot. Let's review them. Autopilot has suggested a set of arguments, meaning the data structure the agent receives as input and returns as output. Let's check this suggestion. First, we have the input schema. Everything matches our expectations. Autopilot detected 4 required fields. City, the city where we're searching for a restaurant. Cuisine, the preferred cuisine type. People, the number of participants. And max budget, the maximum budget per person. City and cuisine are text fields. People is an integer and max budget is a decimal number. At this stage we can rename variables, add descriptions or add more variables. In our case everything looks correct, so no changes are needed. Let's move on to the output schema. Here everything looks very professional. The main element is the recommendations list, a list of restaurants returned by the agent. Each item includes name, the restaurant name, description, a short description, rating, a score, and recommendation, a short explanation of why this place is worth visiting. Additionally, the agent included message field, an explanation of why no results were found, with suggestion to modify the inputs, example try a different cuisine, city, or increase the budget. Such an output structure gives us great flexibility. We can easily process it, forward it to another team, display it as a list, or save it to a file or PDF. So there's no need to modify anything, the structure is clean and follows best practices. Let's click Accept Suggestion and continue. Now we move on to something that defines the personality and behavior of our agent: prompts. Autopilot generates 2 components: system prompt and user prompt. The system prompt describes the role of the agent and how it should generally behave. The user prompt is a template of the query the agent will receive from the user using dynamic input values. Let's start with the system prompt and see how Autopilot defines the agent's role. The agent is clearly defined as an assistant helping users find a restaurant for team lunch, based on preference like city, cuisine, group size, and budget. The next instructions are very precise, guiding the model step by step. Search for the restaurants that match the criteria. For each, provide a name, location or description, rating and recommendation. List 2 or 3 best matching options. If nothing is found, explain why and suggest how to change the criteria. The system prompt ends with an important note. The agent must only use the tools and sources we provide. This helps us avoid AI hallucinations, fabricated information. In my opinion, the prompt is well written, clear and understandable. Let's click Accept. Now for the user prompt. Let's see what Autopilot proposed. It was generated using dynamic variables, city, cuisine type, number of people and budget. It forms the query the user asks the agent. It looks great, so we can click Accept. Now we will have complete prompts, input and outputs arguments too, but the agent still doesn't know where to fetch restaurant data from. And this brings us a key part: tools. Autopilot analyzed our case and informed us the agent needs at least one tool to search the web. In our case, that tool is the restaurant search tool, marked as critical. We will use existing GenAI tools: web search for finding restaurant pages, and web summary to extract useful info like ratings or descriptions. But before we do this, we need to configure the connection in integration service. We go to integration service, search for GenAI, click UiPath GenAI activities. Now we click Connect to UiPath GenAI activities. And connect. As we can see, the connector has a connection status of connected, which means the connection has been established. Once connected, we return to the agent project. Let's rename the agent to Team Lunch Planner. We now go to Tools, click Add Tools, then choose Activities and pick Web Search. We use the connection we just configured. Next, we do the same for Web Summary. Again, choosing the GenAI connection. It's worth mentioning an extra option: guardrails. These are rules we can add to tools to validate inputs or outputs. For example, check if the user provided a city or whether the budget isn't too low. In this tutorial, we won't configure them manually, but for production use, they're valuable. They enable error logging, filtering, or even escalation to the user when input is insufficient. Okay, we're done. Our agent now has both tools connected. It can search for restaurants and analyze found pages. Before we run the agent, let's visit the Properties panel on the right. Here we can configure an AI model parameters. UiPath lets us choose between different models. In the community version, only GPT-4o from November 2024 is available. You can also use a custom model if you have one. We can set the token limit, that's the maximum size of the response. There's also the temperature slider, the creativity level. This controls how original versus conservative the answer will be. Lower values make the agent more deterministic and fact-based. Higher values allow more diversity. Since we want reliable restaurant data, we will set creativity to 0 to avoid hallucination. This panel also includes Agent Score, used to evaluate your agent. Once you open it, the score is calculated across 4 areas. Prompt, quality, clarity, consistency, tools, relevance and correct configuration, input schema, clarity, usefulness, and evaluations, number and quality of test sets. Our prompt got 80 out of 100, so very good. To improve, we could include a demo with example input and output. Tool scored 93, excellent. Input schema got 100, so perfect structure. And evaluations are 0 for now, which is expected. We haven't added any test sets yet. So, our agent is now fully configured. It has a defined prompt, inputs, output structure and two tools, web search and web summary. Now it's time to run a test and see how the agent handles a real query. Click Test on Cloud and enter test data. City Szczecin, cuisine Asian, number of people 10, budget 200 zlotys per person. Okay, so click Save and test. The agent returned a matching restaurant recommendation complete with rating and description. Let's run a second test. Keep the same cuisine, but raise the budget to 300 PLN per person. Again, the agent returned results as expected. All looks good. Now change the cuisine to Italian and leave the same budget. Let's see what the agent finds. Once again, we received 3 restaurant suggestions with description, rating and reason why it's a good lunch spot. The results look solid, so let's add them to the evaluation set. Click Add to Eval set. And here we can review the result we just got. We can review them here. And by clicking Add to Default Set, we can add them to our evaluation set. Now go to the Evaluation Sets tab and click Run Evaluation Set. The evaluation process is complete. We scored 83.33% using the default LLM judge. This means our agent met expectations in about 80% of cases, generating relevant and well-structured recommendations. Let's analyze the results. In the results tab, we see separate scores per scenario. One got 90%, another 85%, another 75%. Now let's go back to the agent score and click Recalculate. The agent score increased from 53 to 75, which now qualifies as excellent. This shows how tests directly impact system-rated quality. The evaluation section is now filled with a score of 55 out of 100. So why not more? Because we only used 3 test cases. The recommended number is at least 30, especially in production. It's best to include a wide variety of cases and edge scenarios. For this demo, 3 tests are enough, but we have seen the full cycle of creating and evaluating an agent in the agent builder. Our agent found suitable restaurants and presented them in a readable format. In a real use case, we could send this to the team or even automate the reservation, which could also be automated. And what if the result wasn't satisfying? Thanks to the flexible agent approach, we can tweak things. In the agent missed key info or wasn't clear, go back to the prompt. For example, if you want the agent to always return a price range, not just a budget check, we add that to the system prompt. Autopilot gave us a good starting point, but we are responsible for the final polish. Web search plus summary is a powerful combo, but we could also add context, letting the agent use internal company knowledge. For example, create a list of team's favorite places or company approved vendors and attach it as context. If responses are too short or too long, try adjusting max tokens or temperature entry tests. It's a good idea to test the agent on various scenarios, different cities, cuisines, budgets, to see if it always behaves reasonably. Studio Web even has built-in evaluation sets for automatic agent scoring. While that's a more advanced topic, remember, you can continually improve the agent using these scores. If you ever notice hallucinated content, responses with made-up data, lower their creativity or refine the prompts to enforce tool use instead of imagination. It's important the agent relies on real data, which is ensured by using web search and summary. After making changes, rerun the agent to see if the result improves. This cycle test, analyze, improve is a natural part of building agents. Based on results, you can improve the prompt or other elements. Alright, congratulations! We have just built a working AI agent using UiPath Studio Web and Autopilot. In this episode, we went from idea to a working solution that searches the web and delivers practical information, saving us time. We use generative AI supported by tools that connect to live data, making our agent useful in real-world situations. I hope that after this video, building AI agents in UiPath is no longer a mystery to you, and that you will be able to build and test your own agents with confidence. I also hope that you will leave a thumbs up and subscribe to my channel to stay updated on future videos. Thanks again for watching, take care and see you soon, bye!